This lesson is about logarithm rules. There are three important logarithm rules: the product rule, the quotient rule, the power rule, and actually there's a fourth important rule too, the change of base rule. We'll get to that at the end. Let's start with the definition of the product rule of logarithms. It states that log of the product a times b is equal to the log of a plus the log of b. Now this is really interesting because notice that log of multiplication is equal to the addition of two logs. Multiplication becomes addition in the world of logarithms. So here's some examples. Log of 35 is really log of 7 times 5. So you can break it apart into an addition problem, log 7 plus log 5. Here's another example. Log of 385. I can break that down into log of 5 times 7 times 11, and then I can rewrite it using the product rule to write log of 5 plus log of 7 plus log of 11. You can even use this rule in reverse, that log of a plus log of b is equal to the log of the product of a times b. Here are some examples. Log 5 plus log 11 is actually equal to log of 5 times 11, which is log 55. Here's another example with more addition. Log 3 plus log 5 plus log 2 is equal to log of the product 3 times 5 times 2, which is really log 30. Here's our next rule, the quotient rule of logarithms. Keep in mind that quotient just means division. So, log of a divided by b is equal to log a minus log b. Notice here, in the world of logarithms, division can be rewritten as subtraction. Here are some examples. Log of 13 divided by 5 is actually log 13 minus log 5. Notice the numerator is first, and then you subtract the denominator. Here's another example. Log of 12 divided by 7 is really log 12 minus log 7. You can also use this rule in reverse, that log a minus log b is equal to log of a divided by b. Here are some examples. Log 52 minus log log 4, is actually equal to log of 52 divided by 4, which is log 13. Here's another example. Log 64 minus log 8 is equal to log 64 divided by 8, which is really log 8. You can see how this rule, both rules, the product rule and the quotient rule, have the advantage of simplifying an expression into a smaller expression. Here's your third main rule, the power rule of logarithms, which states the log of a to the power of n is actually n times the log of a. So you can see the exponent inside the logarithm comes out front and multiplies times the logarithm out front. Here are some examples. Log of 13 to the 4th is actually equal to 4 times the log of 13. Or log of 12 to the 7th is actually equal to 7 times log of 12. You can also use this rule in reverse, that if you have a number being multiplied by the logarithm, it can become the exponent on the argument of the logarithm. For instance, 4 log 52, the 4 can go up and become the exponent on the 52. Or 1/2 times log 64, the 1/2 can come up and become an exponent on the 64. So this was really log of 64 to the power of 1/2, and an exponent of 1/2 is actually a square root, and so the square root of 64 is 8. Now here's another rule which is very important. It's called the change of base rule. Namely, if you have a logarithm with any base e and any argument f, you can rewrite it as a fraction in which both logarithm is base 10. So log of base e of f is actually log base 10 of f divided by log base 10 of e. Notice that the little base e becomes the denominator, and the larger argument f becomes the numerator. So, the change of base rule allows you to use our log button on our calculator to calculate any log. Remember that the log button on your calculator is base 10 only. Log really means log base 10. You need the change of base rule in order to calculate bases other than 10. For example, you can easily use your calculator to calculate a log with base 10. For example, log base 10 of 80, you just type into your calculator log, then 80, then enter, and you'll get the answer 1.903, etc. Or you can calculate log base 10 of 200. Just type the button log, then 200, then enter, and you'll get 2.301. Now, however, we can use the change of base rule to calculate logs like these, log base 2 of 7. Your calculator does not have a base 2 button. So you actually do have to rewrite log base 2 of 7 as the argument becomes the numerator and the base becomes the denominator. So log base 2 of 7 becomes log base 10 of 7 divided by log base 10 of 2. You can get the decimals for the numerator and the denominator and divide them, and you get 2.807. That is the answer to the original expression. Here's one more example. Log base 3 of 14. That, remember, the argument becomes the top number and the base becomes the bottom number, both log base 10, so you can use your calculator. So log base 3 of 14 is equal to log base 10 of 14 divided by log base 10 of 3. You can get the decimal for each one and divide, and the answer is 2.402. Here's some practice for you. Use the log rules to expand the following logarithms. The first one, notice, is the product rule, because this is actually log of 3 times 7. And the second one is the quotient rule, because you're dividing. And the third one is the power rule, because you have an exponent on the 6. Go to the next screen to see the answers. Here is some practice to condense logarithms using the same rules. Remember that addition will turn into log of a product, where you're multiplying the two numbers together, and subtraction will become log of division, where you actually have a fraction, and then the power rule states that the number being multiplied by the logarithm can become the exponent of the argument. Go to the next page to see the answers. Finally, use the change of base rules to solve the following logarithms. I'll do the first one for you. Log base 5 of 20. You rewrite it such that you have log base 10 of 20 in the numerator divided by log base 10 of 5 in the denominator. You can type both of these into your calculator and divide, and you'll get your answer. Do the next two problems in the same way. Here's the answer key to the previous problems.